right. Let's dive into the stuff you sent over about linear rails and hard rails for CNC machines. Looks like you're trying to figure out which one is the best fit for the projects you're working on.
Right.
It's easy to get bogged down in all the jargon,
Yeah.
but when you really boil it down, it's all about understanding how these things move and what kind of work they're really built for.
Absolutely.
Our goal here is to help you cut through all that noise and really understand which of these guide rail system is going to give you the best precision, the best speed, and the best long-term reliability for your specific machining needs.
That's it.
So we'll take a look at what exactly are these things, how do they differ from each other, and what are the key questions to ask yourself to make sure you're making the right choice.
I think that's a great approach. I think a lot of folks, when they're first getting into CNC machining,
Yeah.
they get overwhelmed by the sheer number of components and the kind of subtle differences between them.
Totally.
But focusing on those core principles is going to help you make the right decision.
Exactly. So let's start with the basics. What exactly are linear rails?
So linear rails are sometimes called linear guides or linear motion systems, and these are systems that are designed to provide extremely smooth and precise linear motion.
Yeah.
So you've got machine components moving along a very specific path,
Right.
and they do this by using rolling elements.
Okay.
So think tiny balls or rollers, and these things glide along a very precisely machined track.
Okay.
And because of that rolling motion, you get incredibly low friction.
Right.
And that low friction translates to faster operation. You can achieve higher speeds. You can achieve more precise results.
And we've even got a visual here for folks to take a look at that really illustrates how these components all fit together.
And I think that visual is really helpful because you can see how those rolling elements are captured within the bearing blocks.
Yeah.
And how that allows for that very controlled movement along the rail.
Precisely. And I think that's really important for the type of work that you're describing here, where you're focused on that precision and speed.
Right. And especially if you're thinking about doing things like
Yeah.
small intricate parts or mold work,
Yeah.
where those tolerances are extremely tight.
Now, on the flip side, we have hard rails, and sometimes they're referred to as boxways, and these are completely different animals.
They are.
Because they're not separate components. They're actually integrated directly into the machine structure.
Right?
Oftentimes, they're cast as part of the machine bed itself.
Exactly.
Or they're very precisely machined into that bed.
Yeah.
And this integrated design gives them incredible strength and stability.
That's it.
So if you're thinking about working with some really tough materials or doing some seriously heavy-duty cutting,
Yeah.
hard rails might be something that you're thinking about.
For sure.
And we've also got a visual here that really shows that construction.
And you can really appreciate when you look at that image.
Yeah.
The sheer mass of a hard rail system.
Yeah.
It's really a testament to its ability to handle those heavy loads.
Exactly. So I think what's really fascinating here is that we're looking at two fundamentally different ways to achieve movement.
Right?
As you can see in the sources you sent over, linear rails are all about that rolling motion.
It's like a skateboard on a smooth ramp.
Exactly, yeah, and that allows for speed and efficiency.
Right?
Hard rails, on the other hand, use sliding contact.
So it's more like dragging a heavy box across the floor.
Right. It takes more effort, but it provides a different kind of stability.
It does. With those large contact surfaces,
Yeah.
you get a very solid and stable platform for your cutting tools to work from.
Let's dig a little deeper into hard rails, especially since you mentioned the possibility of doing some heavy cutting and maybe working with tough materials like steel.
Okay.
This is where hard rails really shine.
Yeah.
Because they are so integral to that machine structure.
Right.
They offer exceptional rigidity.
Yeah, like having a rock-solid foundation.
Exactly. And oftentimes they are crafted from a very specific type of cast iron like mehanite.
Right. Mehanite is known for its vibration damping properties, which is really important when you're taking those heavy cuts.
Absolutely, because you want to minimize that chatter and ensure accuracy.
Absolutely.
But there is a trade-off here. With that direct sliding contact, you get more friction.
You do.
So while hard rails are incredibly strong,
Yeah.
they're not as fast as linear rails, and they require very careful and consistent lubrication.
Yeah, lubrication is key with hard rails because without it, you can get excessive wear, you can get heat buildup, even something called burning.
Right, and then there's also this phenomenon called crawling,
Crawling.
which is basically,
Yeah.
it's this jerky, uneven movement that can occur when the friction becomes inconsistent.
Oh, I see.
So you really got to make sure that you're maintaining that lubrication properly.
Right, and I think that's something that a lot of folks don't necessarily appreciate when they're first getting into CNC machining. That lubrication is not just a one-time thing.
No, it's an ongoing process.
It's an ongoing process.
And you got to be very diligent about it.
Absolutely. And I think one of the things that also is worth mentioning is that because hard rails are so integral to the machine structure,
Right.
repairing them can be a much bigger deal.
It's not a simple swap out.
No, it's not like replacing a modular linear rail.
Right.
You're often talking about some serious machining and scraping to get things back into spec.
Then now let's shift gears a little bit and talk about linear rails.
Okay.
If your focus is really on precision and speed,
Yeah.
especially if you're working with intricate parts, maybe smaller molds,
Right.
materials like aluminum,
Yeah.
then linear rails are definitely worth a closer look.
They really excel in those applications.
They do, and that's because that rolling motion minimizes friction so you can achieve much faster speeds.
Right, less resistance to movement.
Exactly, and you can also achieve more accurate positioning of that cutting tool.
Absolutely.
So think about it, less friction means less heat generation, which is particularly important when you're working with a material like aluminum.
It is aluminum's very sensitive to heat.
Right, so you want to avoid any kind of warping or distortion.
Precise.
And of course, that reduced wear and tear on the components means that you're potentially looking at a longer lifespan for those linear rails.
Yeah, and an easier replacement down the line if you do need to service them.
Exactly, and that's a big advantage because with linear rails, you can typically just swap out the individual components
Right,
rather than having to do a major overhaul of the machine's structure.
which can be a big time saver and a cost saver.
Absolutely, and another key advantage here with linear rails is the ability to pre-tension them.
Pre-tensioning.
Yeah, so what that means is you're essentially eliminating any microscopic gaps or play in the system.
Okay.
So you get incredibly high precision with virtually no backlash.
So it's all about that really tight control over movement.
Precisely so. With all of this in mind, the big question becomes, how do you actually choose between these two?
Right.
And I think it really comes down to understanding your primary machining applications.
Your bread and butter, so to speak.
Exactly. What are you doing day in and day out? The sources you sent over provide some helpful guidelines.
They do?
If you're mostly working on smaller to medium-sized parts,
Yeah.
and materials like aluminum and high speed and precision are critical for you,
Yeah.
then linear rails are probably the way to go.
They're especially well suited for aluminum because of that speed advantage.
Exactly. You can really push those feed rates with aluminum on a linear rail system.
You can.
On the flip side, if you're machining large components,
Yeah.
tough materials like steel
Okay.
and heavy cutting is your norm,
Right.
then the rigidity and the load-bearing capacity of hard rails are going to be more important.
They're built for that kind of heavy-duty work.
Exactly, and they're generally considered better for steel because they can handle those higher cutting forces.
Absolutely.
So let's think about some practical questions you should be asking yourself.
Right?
What's the typical size of the work pieces that you're going to be dealing with?
Okay.
What materials are you going to be working with most often?
Got it.
How critical is ultra-high precision for you, especially at those faster speeds?
Okay.
Is high-speed machining a must-have? And of course, what's your budget?
Right, because these are not insignificant investments.
They not.
And you need to factor in not just the initial cost of the machine,
Yeah.
but also the potential long-term maintenance costs.
And it's interesting to note that while linear rails might have a higher upfront cost,
Okay.
their lower maintenance needs could actually make them more efficient in the long run.
That's a good point.
So you're really looking at the total cost of ownership
You are.
over the lifetime of the machine.
Exactly.
Now, here's where it gets really interesting, and this is something that your sources highlighted.
Okay.
Even if you occasionally need to do some heavy cutting,
All right.
but your primary work involves those smaller, more precise parts,
Okay.
you might still be better off with a linear rail machine.
Interesting.
You can always adjust your cutting parameters for those less frequent heavy jobs.
I see. So you're saying you can kind of work around the limitations?
Exactly. You might take lighter passes, for example.
Right.
Or you might reduce your feed rates a little bit.
Okay.
But for the most part, you're still getting the benefits of that speed and precision that linear rails offer.
I see.
Conversely, if heavy work is really your bread and butter,
Yeah.
then a hard rail machine is probably the more sensible investment.
It makes sense to go with the tool that's specifically designed for that purpose.
Right, and it's really built to withstand those rigorous demands.
Exactly.
Now, another factor to consider here
Okay.
is the impact of material choice and maintenance.
Right, because those two things are often intertwined.
They are. We've talked about how linear rails are particularly well suited for aluminum machining
They are.
because of that speed advantage.
Right.
But also, some linear rails come with features like triple sealed blocks.
Triple seal.
Yeah, so these blocks help to keep out contaminants,
Oh, okay.
and they reduce the need for lubrication.
So that's a big advantage in terms of maintenance.
It is.
Because you're not having to constantly lubricate those rails
Exactly. And it also helps to extend the lifespan of the components.
and reduce the risk of contamination.
Precisely. So these are the kinds of details that can really make a difference in your day-to-day operations.
Yeah, those little things can add up over time.
But so bringing it all back to you,
Right.
what does this all mean for your specific situation? Ultimately, choosing between linear rails and hard rails for your CNC machine
Yeah.
comes down to understanding your core needs and setting your priorities.
Right. There's no one-size-fits-all answer.
There's not. It's about finding the right fit for your specific applications.
Exactly.
Are you primarily focused on high-speed, high-precision work,
Okay.
maybe with materials like aluminum?
All right.
Then linear rails seem like a strong contender.
Yeah, they're definitely worth considering.
But if you're tackling heavy loads,
Yeah,
tough materials like steel, where that rigidity is paramount,
right.
hard rails might be a better fit.
They might be.
So this raises an important question for you to consider.
Okay.
Thinking about your most frequent projects,
Right.
which of these characteristics, that high speed and precision,
Okay.
or that high load capacity and rigidity,
Got it.
would have the biggest positive impact on your results and your overall efficiency?
That's a great question to ask yourself.
As you continue to explore this, remember that both linear rails and hard rails offer distinct advantages.
They do.
The key is to weigh those advantages against your specific requirements.
Right.
Your workpiece size, the
Mhm.
material you're working with, your precision needs, your speed demands, your budget, of course,
Yeah.
and how much maintenance you're prepared to handle.
Right. Those are all crucial factors.
By carefully considering all of these factors, you can confidently choose the guide rail system that's going to maximize your CNC machine's performance and its cost effectiveness.
Absolutely.
And I'll leave you with one final provocative thought.
Okay.
Imagine a future where we might see hybrid systems.
Hybrid system.
Yeah, combining the strengths of both linear rails and hard rails.
Interesting. So you're thinking something that offers both the speed and precision of linear rails
Yeah,
and the rigidity and load capacity of hard rails.
exactly what might those systems look like? What new possibilities could they unlock in the world of CNC machining?
It's a fascinating concept.
It is something to ponder as you make your decision.
Definitely food for thought.
Thanks for joining us on this deep dive.
My pleasure.
We'll catch you next time.